In this tutorial, I'm going to explain how we can use Excel to plot for the interaction of two continuous variables. In this example, I'm going to use the very classic MPG dataset. In this dataset, there's a variable called weight, so the car's weight, and then car's horsepower, and both of them are continuous variable. And then there's an interaction. So we just to see whether this interaction is significant. So, and then if the interaction is significant, how we can plot it. Since that both of the weight and the horsepower are continuous variables, so we need to create, essentially in our mind, we can have an idea that we're going to calculate the minus 1 standard deviation of weight and plus 1 standard deviation of weight. Similarly, we're going to calculate the 1 standard deviation minus 1 of the horsepower and plus 1 of the horsepower. By doing so, we're going to get 4 data points of y. By having 4 data points, we can then do a plot to plot their interaction and to see their pattern. Okay, so now let's shift to SPSS, and I'm going to use SPSS in this tutorial. So this is the SPSS. I'm going to post a link to this data set and you can download. And so I'm going to put a link down below if you want to look at this webpage to see more information about this data set. And I just create interaction variable. So you come to the this data, yes, you will see that. So this is the variable I just created, and essentially it's the interaction of the weight and horsepower. And since I already created, I'm not going to do it again. And I'm going to put the syntax down below. It's really interesting to see how you are not sure how to write this syntax. Of course, there are other ways to do that, but this is the way I did that. And so we're going to just run a regression, yes, linear regression. And also I just did a practice earlier, so let me just reset. So essentially you're going to put, this is the y variable, yes, the MPG miles per gallon, and then the weight, and then the horsepower, and then the interaction, the one we just created. And then we can just run it. As you can see that interaction, the p-value is smaller than 0.05. That means that interaction is significant. So with that, we can do a plot to see the nature of the interaction. So now let's move to Excel, and I'm going to show you how we can do that. This is the Excel. Actually, I prepared earlier. Let me explain briefly. Yes. So this is the Excel. Yes. And this is the SPSS output. So earlier, as mentioned, that this is our model, yes. And so we're going to put the B0, B1, and B2, and B3 here first. The easier way to do that is you just double click and then copy that and then just paste it here. That will be give us a more accurate. And this is the weight, because that's a lot of decimals. Actually, this is very critical, so we want to make sure we get it right. So actually, this is this is not exactly what we want. Actually, this is okay. Actually, it looks a bit weird, just like. But anyway, it's a very small number. Yes, it's essentially 0.00005. So it's a very small number. So this is a very small number, but I mean, it doesn't matter either how. I mean, this is not the focus of this tutorial. As long as it's significant, we can do the interaction plotting. Now we got the model, yes, and then we need to create a value of -1 and +1 of the weight and horsepower, yes. So that means that we need to know the mean and then the standard deviation for both of them. So we can just like do discrete. Actually, you can just put the horsepower and weight here. I just did a practice earlier, so and then click OK. So we're going to get the mean of the horsepower. Yes, the mean of horsepower, and then the standard deviation, and the mean of weight, and then the standard deviation of weight. And then the -1 standard deviation essentially is the mean to minus the 1 standard deviation. Yes, so that's what we then we get the data point. Yes, and then we're going to the mean plus. Yes. Similarly, we're going to do the same thing. The mean here, mean minus the here, and then the mean plus this one. Yes. So we got 4 values. So by we have 4 values, we're going to create 4 data point to plot. B0, and then both of them are, and then weight -1. Yes. So basically, is this one to multiple the weight -1, and then plus the horsepower also -1. Yes. So horsepower. Yes, and then this -1. So basically, in this way, is both of them are -1. Yes, and then this is the let's just do it one by one. Then in this is the horsepower -1. Yes, and the weight is +1. So the weight actually are going to times the +1, and then the horsepower actually is going to horsepower. Let me see. Horsepower actually is the -1. Yes, and then plus the horsepower -1 times the weight. Let me double check the first one. So C3 is the weight. That means that is the E10. E11 is the E11 D3 CDE. I think it's correct. Okay, and then this is the constant is the same. Yes. So and the weight here is -1. Yes, and then the horsepower is +1, and then yes, these two. Yes, again these two, and then lastly we're going to get the plus this one plus this is correct, and then D3 is the F11. Yes, and then this one, how should I say, this one times this one. Yes, and then so we got 4 data points. Yes, so then let's plot the chart to see how it looks like. Okay, I think that's correct. I think the only thing that we need to do is that we need to change the format of this number from the scientific notation to be the general, and then we can also I mean, push the may slightly make better, yes. I mean, and you can add a title, yes, and then this is a MPG, yes, and then this is the weight, and then we do not need a title, and then you can also solid line, no border, but you can this become solid line, black color. This also solid line, black color, and we might not need this. And you can also use more, also black, yes, but you want to use the other format, a dash line. Okay, so this is the figure we got. So what does it mean? As you can see, that the first thing first is that these two slopes are different, yes. So one is steeper than the other one, yes. The solid line is steeper than the dashed line. So that's exactly the nature of the interaction, yes. If you plot like two lines, in generally a significant interaction means that the slope are different. Practically, what does this figure show? So this figure basically shows that, I mean, this is -1 standard deviation, yes. So that means that this actually, I know this is a bit counterintuitive, but let me change the solid with dash to make more sense intuitively. How can I do that? Okay, let me change it because this line is minus horsepower. So let me change, this is dash line and this is the solid line to make more intuitively make sense. So this dash line means that this is less horsepower and this is more horsepower, yes, because this is the 1 standard deviation positive, this is 1 standard deviation negative, yes. So that means that this has more horsepower than this one. And so overall, if the car have less horsepower, in generally the mileage per gallon is better. So that kind of makes sense, yes. So again, so the dash line is on the top of the solid line. That means that the horsepower when it's lighter, I mean when it's the horsepower is smaller, then it's better in terms of the miles per gallon. The other dimension is look at the weight. This is heavier. This is a heavier car. Heavier side is more not as heavy as lighter the car. So overall, if the car is less heavy, then the mileage per gallon is better. That makes sense, yes. I mean, if the car is too heavy like this on this side, generally the miles per gallon is not that good. So again, the first observation is that if the car is heavier, the my MPG is lower. Yes, so this is one main effect. Yes, the effect of the weight on the MPG. Another effect is that if the car has larger horsepower, MPG is lower. And then, so these two are the main effects, and the other one is that the interaction effect. As mentioned, that the interaction effect is significant. So visually, the idea is that these two lines differ in terms of slope. But what exactly it means? Let me just how should I say? Is there any shape I insert? Okay, shape. Let me just say that. So the difference is here. The difference is here. And the So this, 1 second. So what it means that if the car is not heavy, then the horsepower actually make a big differences in terms of mileage per gallon. But if the car is very heavy, actually the horsepower, the effect, the impact from horsepower doesn't matter. So of course, still overall, as you can see that less horsepower is better than more horsepower on the measure of mileage per gallon, but the difference is smaller than this one. So that's the nature interaction. Yes, that's so the interaction. So that's exactly the nature that what these two slow are differ in terms of these two lines differ in terms of slow. Because if these two lines are exactly the same slow, for instance, let me just say that if these two lines have exactly the same slow, yes, the slow are exactly. Oh, this is hypothetical. Let me just put that this is red line. This is hypothetical, yes. This is not a real line, but just a hypothetical that if there's no interaction and these two lines are very parallel, yes, then that means that the differences are the same, yes. That the differences on these two sides are the same. But of course, this is the fact is that these two slope are different. That means that lead to the differences. This is bigger than this one. Hopefully it makes sense. Okay, then my question say that, okay, how about I want to know that the slope of that slide, it looks steeper. It looks steeper than the solid line, yes. Whether this slide is, the slope is significant or not, yes. And that could be a question, yes. But that's, we can test that actually, and then you can have a p-value for this one. But this is a bit beyond the scope of this tutorial, and you really want to know that, how to test the p-value for this solid, the dashed line and the solid line, let me know, and I might make another tutorial regarding how to calculate the p-value for the dashed line and the solid line in this situation. Okay, I think that's it. Thank you for watching. If you have any questions, feel free to leave a comment down below. Okay, that's it.